Hello everyone, Gaza Mutkarsh, and I welcome you all to this session on data automation with Python scripts. So guys, let's have a look at the agenda for this session. The agenda for this session includes writing, let's say, data transformation scripts, which is what we refer to as repeatable workflows. Besides this, we'll be looking at how to write, let's say, how to transform the data using modular scripts where we'll be creating different functions. So as far as this example is concerned, we'll be creating two functions, one for, let's say, synthetic data creation, next for data cleaning and transformation, and maybe the third function, let's say, to call these two functions. So guys, so far in the previous session we have discussed about data cleaning and pre-processing in pandas. So guys, let's switch to the Jupyter screen. So guys, currently we are in the Jupyter screen. So let's understand the entire process. Let's understand the concept of repeatable workflow. So a repeatable workflow is a structured pipeline of data operations, right? So when we talk about data operations, we start from data reading, data analysis, data cleaning, data transformation, data aggregation, and summarization as well. All right, etc. That can be reused without manual intervention, and it can be scaled as well depending upon the, let's say, processes or the tasks involved. So it helps ensure consistency and reliability in data processing tasks. So what are the tools that we'll be using? To implement this, the tools that we are going to use are going to be NumPy and Pandas. So as we all know, we are familiar with these two libraries. Pandas is a high-level library for data manipulation using data frames and series, and NumPy is a low-level library for numerical operations, efficient array processing, and even matrix-related operations. So what are the benefits of creating such a workflow where we can write the data transformation scripts? So the benefits include version control friendly. We can track each and every change. Testable, so it is easy to write, let's say, unit test for the transformation logic, and it is pipeline ready. So these kind of workflows can easily be integrated into some ETL or ML workflows. So ML is machine learning and ETL is extract, transform, load. All right, and ML over here is machine learning. So we can write such workflows even for machine learning or ETL operations. So guys, these are the benefits. Now let's understand our use case. Over here, our use case will be, let's say, to generate some synthetic data, and accordingly we shall proceed. So let's understand the three scenarios that we have. The first is to generate sample data, sample synthetic data. The second option, the second, let's say, the second function goes into cleaning and transformation, and then there's third function that calls the above created functions inside the main functions. So these are the three operations that we need to perform, and we'll be writing this in modular format where we'll be creating different functions for synthetic data generation, for data cleaning and transformation, and then to call these two functions. So in the first step where we are supposed to generate the synthetic data, over here the objective is to create a function that takes the file path as argument and add the following functionalities. So what are the functionalities that we have over here? We have to generate sales and profit data for different regions and products for a specified date. All right, now date we can set accordingly. We have to add null values and duplicates because we want to test, because we'll be cleaning the data as well, right? So synthetically we'll be adding, we'll be populating the data with some null values and with some duplicates, and then towards the end we'll be saving the file. So essentially over here we need to, let's say, we'll be creating a table, let's call this sales data, and this is raw sales data, where I'll be having features like date, then region, product ID, sales, and profit. And for synthetic data creation we'll be using the NumPy functions, and for creating the data frame we'll be using pandas. So guys, let's create this function. Let's call this generate sample data. All right, this is the function that I'm creating, and it takes, let's say, file path. It takes the file path. File path currently I'm setting it as raw sales data.csv. This is the file path that I've set. All right, now the objective of this function is to generate sales and profit data. So let's see how are we going to generate this data. Now to ensure randomness, over here I'm setting the seed. This ensures that data is generated randomly based on, let's say, if I'm using this particular seed, so it will always be same, right? So it ensures consistency while generating synthetic randomness. Then over here, first of all, I need to set the dates. So dates, for creating synthetic dates, over here I'll be using pd dot date range, and in this date range over here I'll be passing, let's say maybe I'm considering data from 2023, right? So this would be 2023 01 01, and how many periods do I need to generate this data? 100. So this is going to generate data for 100 days starting from this particular date. I'll show you. So if I run this, first of all, I think I have to import pandas and numpy. All right, I'll show you this separately. So clearly we have imported numpy and pandas, and if I show you these dates, I'll show you maybe top 10 dates. See, these are the dates, and because the periods is 100, so currently by default the gap is, or let's call this, the frequency is 1 day. All right, the frequency is 1 day, and what is the length? What is the length of these dates? It is 100. So periods 100 means generate, let's say starting from this date, generate 100 consecutive dates. So this is the first date column, or let's say the dates data that we have, right? This is the dates data. Then I need to create data. So the data that I'm going to populate over here will contain date, and date will be fetched from np dot random dot, let's say, choice, and the choice that I'll be passing is date, and the size is going to be 100. All right, the size is going to be 100. After date I'm giving region, so the region is going to be np dot random dot choice, and the choices are east, then west, then north, and then south. All right, and size is going to be 100. Then after date and region I need to pass, see, the next column that I need to pass is product ID. So as far as this product ID is concerned, this would be np dot random dot random integer. All right, and let's say I'm considering integers from 100 to 110. These are the 10 different products, and the size that I'm passing over here is 100. All right, so these are the different products that I shall be creating. After the product ID I need to pass sales. Now sales data is np dot random dot, I'll be using random normal values, so normal, and let's say the mean that I'm setting is 500, and the scale, as in the standard deviation, that I'm setting is 100. All right, and the size that I need to pass is 100. So after the sales I'll be creating profit. So np dot random dot normal, so over here I'll be setting this to 50, and the scale that I'll be setting over here is 20, and the size will be 100. So we have set date, we have set region, product ID, sales, profit. All right, these columns I'm setting up in the data frame. Now over here df would be pd dot data frame. In this data frame I'll be passing this data, and we do have the data now. So all these columns would be populated in this data. Now because see, this part was synthetic data generation. This was synthetic data generation. Now moving forward we have to set, let's say, adding null and duplicates. All right, so how do I add null and duplicates? So over here I'll be writing iloc, maybe from the rows 5 to 7, and for the column sales I'm setting the values as np.nan. All right, and then df would be pd.concat, and I'd be concating df with df.iloc and :3. So this is adding duplicates. All right, and this is adding null values. All right, so this is what we have done. Now I can save this data to df.tocsv, and I'll be saving it to the file path. All right, so and I can simply print file saved to file path. All right, so guys, this is the function that I've used. This is the function that I've used, and it is going to generate the raw sales data. So let's simply call this function and test. All right, and I don't need to pass the file path. So I'm hoping there's no error. In case we do have an error, we'll work on it. Okay, this is no, this should be np. Okay, so over here the function that I've used is lock. It would be lock. Yeah, so now it says file saved to raw sales data. So if you observe over here, raw sales data is here, right? And when was it created? It was created seconds ago. So we can even read this. Let's call this df1 pd dot read csv, and I can read this data raw sales dot csv, right? Because okay, I have to set index is equal to false. I don't want to add index with this, and the file is saved. And now if I read df1 dot head, so if you observe this, this is the data that we have populated, right? This is the data that has been populated. All right, so guys, this is what we have. And then next, what can be done? So this is the first function, right? This is simply generating the synthetic data. The next function, the requirement that we have over here is, so essentially currently this is not required. The second function over here focuses on cleaning and transforming the data. So what is the objective? The objective of this function is to take the file path and the output path as argument and add the following functionalities, right? So what are the functionalities that I need to add? Read the file, handle null values, drop duplicates, generate sales difference between current sales and previous month sales, or let's say previous day sales. All right, and generate normalized sales. Check, let's say, if profit values are profitable. So if it is profitable means greater than 0. Find monthly sales summary, that is month and region wise sum of sales. And we have to save the transform data to the output path. This is the objective. So over here I'm creating this function as well. So let's say clean and transform data. Now what are the arguments that it takes? It takes file path and the output path, right? It takes file path and the output path. Now first of all I have to read the data, so pd dot read csv, and I need to pass the file path. This is going to be reading the file. All right, the next step is to let's say over here I'm using df is equal to df dot drop duplicates. See, when we're reading this, we do have duplicates. I can show you, and we do have null values as well. I'll show you. Df dot duplicated, df1 dot duplicated dot sum. So we do have null value or duplicates, and likewise I can check null values as well. Df1 dot is null dot sum. So clearly we do have null values as well. So the data contains null value and duplicates, right? So over here I'm dropping the duplicates. So df dot drop duplicates, and I'm saving it in df only. So this is drop duplicates. All right, next we can fill the null values, right? So over here the sales column contains null values, and we know this. So it contains the null values, right? So over here what can be done? So df sales is equal to df sales. So I think it's in lowercase, right? So this would be sales maybe dot fill na, and I'm filling it with 0. So this is handling null values. So this part was, the first part was, let's say reading the file. The second part was cleaning the file, right? This is cleaning the data. Now the third step would be to data transformation. So how can we proceed with data transformation? For data transformation over here I need to create, let's say, the month column, and as far as this month is concerned, or maybe let's say the month is not required. Let's read the problem statement. We have read the file, we have handled null values, we have handled the duplicates, right? Now we have to create sales difference between current sales and previous day sales, and we have to generate normalized sales. First let's create normalized sales. So this is sales normalized. All right, and sales normalized would be df sales minus df sales dot mean. All right, so we have discussed normalization in the previous module, right? So it's the same formula upon df sales dot standard deviation ddof is equal to 0. And then over here maybe I can create month. Month would be we do have the date feature, right? We do have the date feature. Now from this date feature, first of all I need to transform this to date time. All right, so pd dot to date time, and this would be df date. And once I do have the date, right, then I can use dt dot to, let's say, period. And what is the period that I'm using? I'm using the period as month, and I'm setting this to as type string. I'm setting over here to as type string. So this is, let's say I've calculated month, then I do have the normalized sales. Before normalized sales, we can find the sales difference. So df, this would be sales difference. Sales difference would be df sales dot difference dot fill na. I'm filling the null values as well, right? So this would be the sales difference. This is the normalized sales. So these two questions are solved. Now we have to check if the profit values are profitable, means is greater than 0. So I can simply write is profitable. Is profitable, I can write using the np.where function, where I can write df. All right, if the profit is greater than 0, then maybe I can write true, otherwise I can mention false. So guys, we have created these columns, date is transformed to date time. All right, and let's say then these are the modifications or the transformations required. All right, now these are the business problem statements that I'm solving. These are the transformations. Then let's say this is where, let's say, we are solving, or this is where we are analyzing the data. All right, next, what else can be done? Besides this, I can find monthly summary. So for monthly summary, over here I'm defining monthly summary. This would be df dot group by, and in the group by function I need to write month and let's say region wise, month and region wise sales dot sum. All right, month and region wise, over here I've mentioned sales dot sum. I can apply, let's say, reset index to convert this to let's say data frame, right? I'm converting this to data frame. So this is what we have, and over here I can mention this would be monthly summary dot columns, and over here the columns would be month, region, and sum sales. All right, this would be month, region, and sum sales. So guys, this is done. Now I have to save the data, right? So find monthly sum sales summary, month and region by sum of sales. Now we have to save the transform data to the output path. So the transform data is this df only. Df is my transformed data. So maybe I can write transformed data is equal to df dot maybe copy. So this is where, this is the sixth step. Let's say I'm going to save the transformed data to output path. So over here clearly we can see that we have transformed the data, and once the data is let's say transformed, right, then I can simply save this. So this is simply transformed data dot to csv, and what is the path I need to save this upon? इसे हमें output path में save करना है, and I'll set index is equal to false. Over here I'll set the index as false. All right, and then what is this function returning? This function should return few things, right? So maybe I can print data has been cleansed and transformed. So over here I can simply mention that data has been cleansed and transformed. All right, and then maybe we can return two things. I want to return transform data, and I also wish to return the monthly summary. These are the two things that I'm returning over here, right? So in cleaning and transformation, first we have read the file. The first step was to read the file. The second step was to clean the data. Third step was data transformation. Fourth step was analyzing the data. Then let's say I'm computing monthly salary, monthly let's say monthly sales report summary. All right, and then I'm saving the transform data to the output path, and this is what the function is returning. I'm let's say returning the transform data and the monthly summary. So even this part is done. So next we have the most important function, which is to align, or let's say call these functions one after another. One would generate the sample data, the other would simply apply the transformation on the synthetic data that we have created. So I need to create a main function, all right, where I need to pass input path and output path. So input path is nothing but the original file that I've used, raw sales data.csv, all right, or let's call this sales data 1, all right, sales sample data. This is the input path, correct? And what would be my output path? Output path would be, let's call this transformed sales.csv, all right, transformed sales data.csv. This is the input path and this is the output path. Then I can call the function generate sample data. I need to pass input path, all right. Over here I'm calling the input path, and then because this function is returning transform data and the monthly summary, so I'm calling it, I'm writing this over here. And what is the function that we have used? Clean and transform data. So I'm hoping there is no mistake. I've read the file, I'm dropping the duplicates, then I'm filling the sales with the null values. Then I'm let's say over here I'm converting the date to date time. Then this is let's say how I'm converting the date to month, all right. And then this is the sales difference between current day value and the previous day value. This is the normalized sales, all right, or let's call this standardized sales. I'm simply calling it sales scaled, right? Generate sales scaled. This is done, and then we are checking if the data is profitable. Then this is a monthly summary, and we are simply transforming the data. So let's call this function. So the function used over here is clean and transform data, and in this clean and transform data I need to pass input path and then the output path. So guys, this is done. Now let's call the main function. So main function returns two things. It has to return the transform data and the monthly summary, and once it returns this, I can use it over here. All right, so let's call the main function. Okay, pd.toDateTime. So pd.toDateTime, yeah. So now let's call this again. So guys, over here we can see the file is changed. So let's see the transform data. So guys, we have date, region, product ID, sales, profit, month, sales difference, sales scaled. We can see whether it is profitable or not, and we can also see the monthly summary. So guys, this is month and region wise sum of sales. So guys, this is how we can work with the repeatable workflows, where we have written, let's say, data transformation scripts. So guys, that brings us to the end of this session. So let's switch back to the PPT. So guys, in this session, we have discussed and implemented how to write data transformation scripts, where we have created synthetic data from scratch, and we have also cleansed and transformed the data. So guys, in the next session, we shall be looking at automating file input and output using the Python scripts. Thank you.